Welcome to another broadcast of Global Astronomy Month. I'm your host, Andrew Fazakis, the Night Sky Guy, here on another amazing broadcast, really all about celebrating the night sky around the world. This is a very special, of course, event. This is what we call our Global Star Party. This is something that's been in a staple of Astronomers Without Borders, the originators of Global Star Party, over 17 years in existence, and it still keeps on going. And of course, it's all thanks to people around the world participating in our global community, which is in the thousands across the world in over 140 different countries. People are out there throughout Global Astronomy Month every April celebrating the night sky, our connection to the cosmos. And it's really amazing to see so many young people out there looking through telescopes, thanks to volunteers at star parties. everywhere around the world. And here at Astronomers Without Borders, we're here to support that global community in many different ways. And we're really excited that you can join us today. Please share with us in the comments, whether you're watching on YouTube or Facebook, where you are in the world. Love to see the connection. And even if you're just watching this in a recording after the event, we'd still love to hear where you're watching. And if you have any questions about our guest today that I'll be tuning in with, please do share that also in the comments. And if you're celebrating Global Astronomy Month, maybe you're part of an astronomy club somewhere, we'd love to hear that as well, what club you're with, and maybe what events you've been participating in, helping out, volunteering, or maybe even just attending and seeing what's out there. There's so much going on, and I'm getting messages from folks everywhere, which is really fantastic. Thanks so much for tuning in. Andy's out there from Andrew from the UK. Welcome. Nice that you could join us as well. And just keep those comments coming in. It'd be wonderful to see that. And this is a very special month because, of course, we just came off of that iconic Artemis mission by NASA going around the moon. And of course, that amazing shots shared, one of the most amazing, is showing our planet from the moon. Of course, it's that beautiful blue marble just hanging in the black inkiness of space hanging there. And it really, I think, brings to attention the fact that there are no borders. There are communities around the world. And when we look up at the night sky, it's really a heritage that belongs to everyone around the world. And I'm really excited. So we're going to jump right in because we've got our first guest for our live streams today. And we'll have probably a couple of live streams. We'll see how people are coming in through different locations around the world. But the first one we have joining us is from Cyprus. It's actually this person is very special, has been with Astronomers Without Borders from the very beginning. It's George Trulias, who is our AWB National Coordinator for Cyprus and is also the founder and director of the Kidian Observatory and Planetarium. Wonderful organization. Let's see if we can bring George into the live stream. There we are. Hey, George, can you hear me? Wow. What's the local time right now, George, there? What time is it there? Oh, wow. Oh, that's amazing. Let me see. Hold on. I'm just trying to make sure that audio is working. Oh, I see. Yes. Oh, I think your audio just went off, George. Oh no. Trying to get the audio. Is your mic off, George? No audio. Oh my goodness. George, I can't hear you. Yeah, still no audio. Oh boy. Let's see. We can't hear you. Hold on. Let me see. I can hear you. Anyone who's watching, can you hear the audio now? Let us know in the comments because I can hear you, George, now. You're coming in. So let me see. I'm waiting to see if some people who are watching around the world, uh, they're saying that they can't hear you. I can hear you. Yeah, yeah, I can hear you. They say that your mic is not coming through. So we're gonna try something else here. Hold on. Let's see if I can bring you in here. All right. Let's see. How about now? Let's see. Can you hear me, George?
Yeah.
Yeah,
Yes, I
I
do.
can hear you. Can everyone on the live stream and the audience, can you guys hear?
Hello,
Uh,
everyone again around the world. Can you hear me this time?
I hope so, because I can hear you loud and clear, and it looks really great where you are. You seem like you have a lot of people.
Actually, we have uh, around 15 people, but we had some cancellations. We have a group cancellation of 20 people coming from a company from Limassol because they saw that there was a lot of dust in the morning, so they canceled. But now the clouds went away, and the dust uh, was carried away by the winds in the midday, and we have better skies. Last year it was total disaster with the sky, if you remember. Yes,
Yeah.
but we had few people as
You
well.
never know, right? You
And
never know from one year to the next how the skies
yeah,
are.
but let us pray that it will stay like this tonight. So, shall I
Yes,
pass you
everyone
on?
can everyone can hear. Yes.
Okay, so I'll pass you on to our audience. Since a global star party, and the guy that is talking to us is Mr. Andrew Fazekas. He is Mr. Night Sky. He from National Geographic, and he's a global coordinator for Astronomy Without Borders. And I'm the national coordinator of Cyprus. So I will turn around the camera, and we have Mr. Eclipse Chaser here as well. Mr. Norbert, all the way from Germany.
Germany, yes.
Speak louder.
Hello, hello. Hello,
Hey,
Andrew.
nice.
I'm Norbert from Germany,
That's
and I'm
fantastic.
looking forward to my 10th solar eclipse, total solar eclipse in Spain in August.
Yeah, that's a big one coming in August. Wow.
Of, And the year after, I will be in Egypt with you, of course, with everybody here,
Yes.
to have eclipse from 6 minutes and 22 seconds near Luxor.
Wow, that's a really long eclipse.
It's the longest you ever can have in lifetime, I think.
Well, that's the place to be then. You got to be in the path of totality for 6
Yes,
plus
of course.
minutes. That's
Yeah,
incredible.
yeah. And last year to Mexico, it was 4 and 28 minutes. It was great.
Incredible. I hear there's a lot of people that are heading to Spain and Egypt all along the path of totality. There's going to be huge amounts of people watching
Yeah.
this eclipse.
Malta.
Yeah, and you have to prepare the infrastructure and hotel and flights, and you have to do many things before that. And to you have the weather conditions will be good in Egypt, of course.
Mhm.
Let me ask you, you're an eclipse chaser. What makes
please.
you, what are you passionate about when it comes to eclipse? Why do you do it? Why do you go?
I'm infected. I'm addicted to this because you have so many things around the eclipse. Of course, the corona and the darkness and the cold, and the animals are quiet and the people are screaming, and every location is different. And that's a great moment.
Absolutely.
Andrew, we also have some friends here all the way from
Malta.
From Malta, another beautiful island that we are
Beautiful.
planning to visit soon. I want to visit the Popeye village, yes. And here we have people from Cyprus. Hello from Cyprus. And
Hey,
this little princess here. And we also have more people here from Cyprus again, and maybe a future astronaut.
hi.
And our colleague all the way from Russia here, Mr. Alexander Prokofiev, another eclipse chaser. And we would like to proceed with the presentation because people are waiting now for 20 minutes upstairs.
Yeah.
Do you want to follow the presentation? Okay, I will turn this around so that you can see the presentation. And then after the presentation, we will proceed with observations downstairs. We will proceed with observations of Venus, Jupiter, and the moon.
Fantastic.
Okay?
Yeah, that sounds great.
So, hello,
Yeah, I can hear you.
Andrew?
Yes, I'm here.
Okay, we will proceed with the presentation. Sorry for that delay, guys. So we are still live. So what we present now is going to be live streamed on YouTube. You can find the lecture. You're going to be included. So thank you for your participation. So as we mentioned earlier, we are celebrating the Global Astronomy Month. That was organized by Astronomers Without Borders, 17 years now. I'm the national coordinator of Cyprus, and I'm since the beginning, since this organization was founded. And the Gideon Planetary Observatory is a private initiative that was established back in the year 2008 by me, and we are very proud to say that we are the national coordinators for Astronomers Without Borders, UNESCO International Day of Light on the 16th of May, UNESCO and United Nations Asteroid Day on the 30th of June, World Space Week, 4th to 10th of October every year, and many other projects, of course. And I'm also delighted to be part of the COSMA, Committee on Space Research on the Physics panel. I represented the United Nations World Space Week this year. And we are very delighted, since you're here, to announce to you that we have discovered our 10th asteroid with our research team. So the team here, in cooperation with the NASA ISAC Asteroid Research Campaign, we have discovered only from here 10 new asteroids in the main asteroid belt between Mars and Jupiter. And we also have, except these 10 provisional discoveries, we have 476 preliminary discoveries. So for the preliminary discoveries to become provisional, we need to confirm the trajectory and so on. So I will not get you into more travel with all travels and so on, but I would like to let you know that here we are doing science outreach, science research, we have the educational part with the Gideon Astronomy Academy, we have summer schools, and we also do a lot to support the society with charity events. So we have a saying here from the International Astronomical Union, and they say, the beauty of the night sky is not for sale, but it's free for all of us to enjoy. That's why I was inspired when I was a very young boy, like the age of these two children here. I was 4, 5, 6 years old, no street lights. I was in my granddad's stable with horses, and I was laying back and I was looking at the stars, and that intrigued me, and then I fell in love with astronomy. I always wanted to search and find out what's up there in the sky. But what is really important is to protect the night sky from technology, as we say in our TikTok, what with technologies, and exactly, and of course, this technology, and especially the street lighting and the light pollution that is being used now, is destroying the view of the night sky, and especially in some main cities, some cities like I have experienced in myself, let's say in Hungary, in Budapest, it was difficult to see any star in the sky because of the lights. It also destroys the biodiversity, so we have to give to save energy and protect the night sky from the light pollution. Otherwise, future generation will not be able to have to see these marvels. The astronomers will not be able to observe anything from Earth. And of course, it's very romantic for those of the romantic. So today we're going to go through a journey through our solar system, say a few things about it, and also talk about how the process. Solar system, a group of planets moving around their own star. The most massive object in the system is the sun. And we have the planets orbiting around. And of course, they dance, yes, rotating around their own axis. That's the duration of a day. Rotating around the sun, duration of a year. Okay? But since the ancient times, the sky was a challenge. So they tried to search what was up there. But if they don't have enough knowledge, if they don't have enough technology, what do they do? Of course, they would put their myth, their history up in the sky, and they created a constellation. And every constellation has its own myth. By the way, this is a picture of Apollo Heratis in Curium, in Limassol. And this is a picture it was with the background of the with the meteor here. And here is a picture that we took with the telescope we are going to observe tonight of the moon. So it was taken in the year 2006. So you will be observing the moon like this tonight. So for my friend the eclipse, but for everybody who have never experienced this totality, this is a total solar eclipse. What do we mean by total solar eclipse? From the point of view, from our perspective on Earth, we see the sun hiding behind the moon. So the moon blocks the view of the sun from our perspective on Earth. So this is totality. And that's the time where we can see the very outer atmosphere of the sun, which is the solar corona. Now, last night I was giving a lecture to England, actually, talking about these hieroglyphs here. That was the description of the total solar eclipses in ancient Egypt, and the symbol ahead, and the god Ra, who was the god of the sun, fighting the underworld, and was reborn all the time, reincarnated from the lotus, and came back to life. So this was a very nice myth that was then carried into the Europeans and spread everywhere in the world. And we managed to do publication that we managed to correct this myth transformed with Christianity and transformed even in the cult of Saint George. And we can see this on icons, visible icons and more. But this myth came even after his death in 303. So it's a different story, but you can find it on our YouTube channel. It will be uploaded. There is already presentation about it, that I presented it back in the year 2017 at the conference in the Moscow State University, in Moscow Technical University, and it will be posted again, what we said last year. So ancient people, they try to search what's up in the sky, but what was incredible for them, they honored them as gods. So we have the story of the god Ra. So many myths were applied on the sky. Finally, we had the launch of the first man-made satellite, Sputnik, on the 4th of October 1957, and then we had on the 12th of April 1961 a great step for humanity, giant leap actually. This was the actual giant leap. Yuri Gagarin on a mission that nobody knew he was going to succeed. He was a very brave man, international world hero, and he managed to go around the Earth for the first time. The first guy who traveled around the Earth for the first time. And after that, he visited many countries and he was honored, and he visited Cyprus as well. And this is a picture of the first president of Cyprus, Archbishop Magarios. And he was honored as a citizen. He was given the golden keys of cities, and we honored him with the statue at the municipal gardens in Nicosia, and we have many streets after his name. Now, let's go back to our solar system. So as I mentioned earlier, the most massive object in the solar system is what? Our sun, our star. Now, in Greek, Helios. Helios, yes? We mentioned the ancient Egyptians, and that myth is related to Heliopolis. Heliopolis. So the town of the sun. So let's come back here. We have the sun, which converts hydrogen into helium with nuclear reaction, nuclear fusion. Okay? So actually, it converts 700 billion tons of gas, of helium, no, for hydrogen gas, into 695 billion tons of helium every second. Okay? So it's furthermore large. And we are talking about our star, which is an average size and an average age star. If you come here during the daytime and you observe the sun from our solar telescope, you will see like the picture from this. So, since Galileo Galilei, you know Galileo Galilei is an astronomer from Italy, yes. Galileo Galilei. If he was Greek, George, Georgiou, Andreas, Andreu, yes, has the same name with the same surname. We have this in Cyprus. Anyway, so Galileo Galilei, 1609. He made a telescope, only 3 times magnification. He was able to observe some celestial objects and take log file with with records. Since then, we have been observing the sun, and we have found out that every 11 years, we have a cycle. So we realize that we have what we call a solar minimum, which increase activity up to the solar maximum, and then we have decreased activity up to the solar minimum. So approximately every 11 years, we have this cycle. And we know that when we have more activity, we have more sunspots on the top, which are these things here, and we have more explosions and so on. Now, we are talking about millions of degrees here, radioactive zone that takes even thousands of years or millions of years to come out. And we are talking about the celestial object, which is approximately 4.5, 4.6 billion years old. And here on the surface, we have a temperature of 6,000 degrees at the photosphere. And where we have strong magnetic fields, the plasma cannot escape to the surface, and the temperature drops to 4,000 degrees. Okay, so we see this line which is the magnetic field. Also, we see here the sunspots. Okay, but here at chromosphere, if I remember well, the temperature is 20,000 degrees centigrade. And it's very beautiful because we can see the granules, filaments, and prominences, and sometimes explosions of flares. So the sun now, this is a picture that I took 2 days ago on the 21st when we had the school here. It's very similar. It could be observed like that on that day. Let's go to the first planet, which is very, very near to the sun, Mercury. And the highlighted places here is places where we have discovered water. And of course, the crater where from meteorites falling on the surface. Although it is the closest planet to our star, it's not the hottest planet. The hottest planet is Venus. Venus is the planet we are going to observe today. And you will see it, it has faces like the moon, so you will see it today. Part of it is missing. If you are a little bit, look for the details, part of it will be missing. So I have the picture later to show you. So, what do we have here? We have the so-called greenhouse effect. You know how greenhouses work on Earth? Yes? We trap the heat inside and things grow faster, and we have increased temperature. The same thing. It has very, very thick, very dense atmosphere, so all the heat is trapped inside. So we have raised temperature. So this is the hottest planet. And I have something for you that maybe you didn't see before. I have a picture from 2 missions, from 1 mission, but I also have the sounds from the Soviets those times, where there are a mission, with the sounds of Venus. Enjoy. The sounds from Venera given sets, Venera 11, and Venera 14 is not a very constant. The weather is very, very bad there in the Los Angeles, okay? Yes, and all the visuals are very, very easily destroyed. But we plan now, ESA is planning a new mission soon and so on. So, planet Earth, the planet that we are living on, we are very, very lucky to be here because we know we are intelligent, we call ourselves intelligent. We are the only species killing our own species. Let's hope that we will stop one day, someday, these wars everywhere. And it's a planet where we have water in liquid form on the surface, which is very important for the development of life. But we have the water cycle, yes? So we have water in liquid form, in gaseous states, clouds, and we have snow whites, yes? So water in solid state. And our friend Yuri Alexeyevich Gagarin, who was not in the beginning chosen, he was in the final 10, 7, 12 people that were among the people that they were candidates to go for the mission. But his height, 157, was the best on the capsule. He was a pilot. He was some other things happened, and finally he went. He was the first one there. But he was very brave because they didn't know they could reach him. It's very, very big. His family didn't know about it, that he was traveling to space. So when he was there, although he was a guy from the military, he said, orbiting Earth in the spaceship, I saw how beautiful our planet is, our blue planet is. Let's preserve and increase this beauty, not to destroy it. And we have a military man talking about peace. This is something very important we have to keep. Moon. Everybody knows about the missions over the moon, about the Americans, the Soviets, the Russians, but we also have other agencies like India, Russia, China. Even China sent many, many pictures in a very, very small period of time from the far side of the moon. Is not the dark side, the far side of the moon, okay? Dark side only in Pink Floyd, if you're listening to this. So the far side of the moon, because we have developed technology now, and they have sent in very, very small period of time, so many images that were never sent up to now from all previous missions. And of course, we have the Artemis 2 mission lately that they tried for 10 days, and NASA sent these astronauts to check how it is. So by 2027, with Artemis 4 to have the people on the moon. Mars. Okay, Mars has a similar inclination on the axis similar to Earth. It has poles with ice, and we believe that once, many million years ago, that the could have had thicker atmosphere to preserve water on the surface, and maybe there should have been life before. And the missions are also searching for possibly for fossils. But we have found depth depths. Depths, we find them usually where in near lakes where the river ends, and we create what we call depths. So there we are searching for fossil compound sediments. And by 2033, we try to send people on Mars. Now, that was the inner solar system, and that's the planets we call rocky planets. From here on, we have the remainders from the formation of the solar system, our asteroid belt, the main asteroid belt, because we have some asteroids trapped in the opposite planets. And from there on, we have the outer solar system with the gaseous planets. And as I mentioned earlier, from the 1 million that they were discovered, 10 were discovered here with cooperation with NASA and Harvard Siemens University in Hawaii. Jupiter, the most massive, the biggest planet in the solar system with these zones. Of course, they are related to the activity, and the swirls here, and the red spot, the great red spot, and we believe that this color is related to gases that come out to the surface from the center of the planet. Now, scientists sometimes call it the vacuum cleaner of the solar system because it has so much so great magnetic fields that attracts all them, the debris, and they crush it. Even a comet they don't. If you have a look here, there would be anything else to do. This was the medium side. Yes, it looks like it. The film. Bravo. Bravo, our little friend. Levante modesto. Delfinagin. Look. So, delfinagin. Dolphin. Bravo. So we have clouds, and they look like a dolphin. So, the second bigger is Saturn, another gaseous planet with rings. No, it's not married. He doesn't wear earring because of that reason, as a teacher told me once. A teacher was here, she raised her hand and said, Mr. John, is Saturn married? I said, why? Because it has rings. Okay. Teacher asked me. Anyway, so guys, these rings, from our perspective, from our point of view, they look like this, but actually they are large pieces of ice and rocks that they are coming from one of the moons that has guided and sets water, it freezes, and is attracted around the planet. Let me show you. Now the rings, this is the moon, this is the Earth, and it ejects water here, and comes cold, and this ice is covered around the planet, and we have the rings. two planets that they are very far away from our sun, very cold planet, Uranus and Neptune, with the largest storms in the solar system. Long winters, very cold weather. And of course, we have the dwarf planets, very, very small planetoids or planets that they are not independent, I mean, they are not dominant in their orbit. So we call them dwarf planets. This is Ceres, and this is or Ceres in Latin, which means Dimitra in Greece, in Greek, and this is Pluto with a big icy heart. Now, from the edges of the solar system, we have some travelers. We call them periodic comets, because every certain period of time they go around the sun. Now, these are large ice balls from the formation of the system that every now and then they go around our sun. So, and these comets release some debris and some gas, and these small debris, these small grains of dust that they are left behind in the space, because when they come near the sun, the heat of the solar winds, they melt this ice ball, and some dust, we have the dust cell and then gas state. So these remain in space, and when it passes from that space, rock space, they enter the atmosphere, and we have what we call the meteor shower, or as was previously known, falling stars. But of course, we know that the sun is a star, it's not falling, so now we know that this is from debris from the comets. So all meteor showers are related to this. In France, they call them the tears of Saint Laurent, because they used to be that for the mirror. And this is the comet 67P. 67 is the number in the catalog. It's for periodic Churum Pierasimento. So the two people to discover. This is the farthest dot that we've taken a picture of, Arrow. And of course, we have the horizon mission that is beyond our solar system. And sometimes, lately, we have discovered some interstellar objects. What we mean interstellar? Stellar is star, yes, different solar systems. Interstellar means that it's not orbiting, this comet is not orbiting our solar system, but it travels from one solar system to another. So we call these visitors interstellar. They are not attracted by the sun and far out, yes. So they travel from one solar system to another, and they travel throughout the universe. And this is the third object, third interstellar, 3I Atlas is a project we discovered. We had Oumuamua, and then we had whatever. Borisov, if I remember well. And in this space, we have some beautiful molecular clouds in the Flame Nebula and the Vosper Nebula in Orion Constellation 1, that they built new planetary systems, new stars, and so on. And of course, we have black holes. Black holes, we have one in the center of our galaxy. It's a big body with great, very much, very large mass that even absorbs light. This is a real picture of the black hole that was taken 2 years ago, if I remember well, with what we call interferometry. We connected many telescopes around the world, and this is what we call the event horizon, where up to this point, light can escape from the black hole. But here, not even light can escape. It can escape. That's why we call it a black hole, because it's so massive that it even absorbs light. This light is the fastest thing that we know in our lifetime in the universe, 300,000 kilometers per second. And according to theories, everything started 14 billion years ago with the Big Bang, and then cooling started. And after this explosion, we had cooling, and then we had all the planets being formed, and so on. And since then, the universe is expanding in both directions. So, and these are regular telescopes, because tonight we are going to observe not with our telescope, but we are optical telescopes. Optical telescopes, they use mirrors and lenses. Radio telescopes, they use radio waves, they are antennas. Okay, like a satellite that you watch football, yes, you watch the news from one place on the world to the other through satellites in the universe, some uh, space technology that we use in our everyday lives and we take it for granted. It's like something is happening magically, yes, but there is a lot of technology. So these radio telescopes, they work together, they gather information. This is the Milky Way. So we have radio telescopes. Here we have radio telescopes as well. We work with the NASA Radio Job project and we take measurements from the solar explosions and Jovian explosions on Jupiter. Let's see this. And oops, days. If you want, you can register for our Astronomy Academy, October to June, once every week. Read the sky for pronouns for adults. It is announced every 2 months, and we have 4 sessions, once every week, and you receive your certificate. It's a course for beginners. It's not very demanding. It's nice to have fun and learn. This is our summer school, summer observatory, for different ages, for primary school, high school, lyceum, gymnasium, lyceum. We also have some summer workshops for these ages, for Saturdays, usually in the morning. Here you can find, it's our website, you can find our program name here. Here you can find publications, some information. And if you visit here, our channels, you will be informed about latest news. And on YouTube channel, you will find more news online Science Cafe. Science Cafe, we do them once every month. We do them every last Tuesday of every month at 8 o'clock time. And it's free of charge, and you have the codes there, and you can log in for free from Malta, from Germany, from Cyprus, from Alaska, from Mexico, from Canada, and so on. Thanks for our media sponsor, Ruski Krai and Poltocom Vianellos. And this is what we are going to observe tonight. Tonight we are going to start with observations of planet Venus. Okay, you see a small part on the top is missing. You will realize in detail that a little bit of attention. Then we'll go to Jupiter with the zones. Io, Europa, Ganymede, and Callisto. This is how they will appear tonight. These are the 4 Galilean moons. Why Galilean moons? Because Galileo, when he went to the telescope, he observed Jupiter and he wrote that it was surrounded by 4 stars, but then we realized that these were the biggest and the closest to the Jupiter moons. So they are moons, like Earth has our own moon. Jupiter has many moons, I think 87, I don't remember exactly, I think something like that, 87, 86. But 4 of them are visible with telescope, and we are going to observe them tonight. And quarter moon tonight. So we are going to observe the moon. The sun is here, so the light from the sun comes to this side for its day and night. And here, and sometimes we observe the terminator, and if we have some flashes, we know when something hits the moon when we do research. So what else? That's all, folks. Husbands, managers. So thank you very much for coming here. And now we have to move for observations. If you don't have any questions, Alexander will proceed, or maybe, so I don't keep you upstairs. Maybe Alexander can explain how we do the observations. And then we will go downstairs for the observations, and I can answer all your questions downstairs. Yes?
We must start with answering questions.
Okay, now you want to prepare the telescope. Okay. So, do you have any questions related to the presentation? Okay, you like it?
Was informative.
It was informative.
Can you tell us the rate of methane that zero? Not in the Venus stratosphere.
Ah, yes.
What kind of weather is on Venus?
Yeah, it's very, very
It's rain of
severe
rain.
weather. There's rain of methane gases, and also there is a lot of thunders, which there and a lot of electricity exposed, and it destroys the emissions very, very easily in hours sometimes. This is question. Galileo, so it was informal. Lady? Okay. So thank you. Let me come back to Andrew. Hello, Andrew.
Hello, I'm here.
We we are back. This is what we are going to observe tonight. The moon,
Wow.
planet Venus, Jupiter with Io, Europa, Ganymede, and Callisto, the four Galilean moons. And now we have finished the presentation. People are hanging around the gift shop, and we are going downstairs for the observations.
Ooh, okay. That sounds fun.
Mhm. Do you want to stay with us for the observations?
Well, I'd like to, yeah, we should take a look at the observatory, what the telescope looks like.
Mhm.
Yeah.
Excellent. Do you want to stay on or live, or you want to do another session when we go downstairs?
How about we come back? We're gonna visit with
If
Sweden
you
for about 10 minutes, and then we'll
okay,
if you stay
Sweden.
live, just stay live.
Okay, I will
And
stay here live and I'll keep it on, and I will show you around.
yeah, and
Okay,
we'll be back and visit you in about 10 minutes.
excellent. Thank you very much.
All right, George.
So we have some memorabilia.
So there you go. We've
Yes,
got
there we are. Yes.
we're gonna
Now, Andrew,
hold
he's
on.
based in Toronto now.
Oh,
Yes.
we're just going to see if we can get
Now
the audio.
we will stay on the live.
There we go. So we've muted them. And we're going to go see in Sweden, our national coordinator, Peter Lind. He sent this little video for us. Check this out.
Hi there from Sweden. I hope you're all enjoying the Global Astronomy Month. Here in Sweden, it is, however, rather bright, so it is difficult to have a star party. But nevertheless, I will show you something that has been done during the month of April from us here in Sweden. So I would like to show you something from this little observatory, which is located just outside Malmö city in the southern part of Sweden. This is called the Tycho Brahe Observatory, and it's a rather modest construction perhaps, but we have a couple of very large and nice telescopes there. So let me just quickly show. This is a 16-inch Meade Schmidt-Cassegrain telescope, and it is of course very powerful for the general public to have the possibility to actually look through such an instrument and see something. So we have a lot of public demonstrations and showings here, and the idea is double, so to speak. First of all, you prefer people to actually look with their own eyes into the telescope and to actually get those photons there and have that kind of discovery or aha process that we usually call it. So that's the number one. But on the other side, we also have a astrophotographic capability here with this little powerful refractor, 10 centimeter refractor, which has a very sensitive camera, and it is controlled by microcomputer, which in turn sends images to a very large screen, so that the general public can also enjoy this at the same time as they are waiting to actually look through the telescope themselves. So with this telescope, this astrophotographic system, you have this so-called real-time stacking, which means that you start with a small, rather short exposure, say half a minute, and then it's being offloaded onto the screen, but then it continues automatically and adds new images, half-minute exposures, as long as you want. And that means that on that screen you will actually see something emerging from blackness, more or less. So you see, could be as you see here, a beautiful nebula or something like that. So it's a very striking thing to be able to show our visitors. So some images taken during April with this little refractor, and using this kind of multi-exposure, so to speak. Many of you may recognize these objects, but this is, as you might guess, the Messier 37 open cluster. Rather nice then. And here you have an even nicer, the famous double open cluster in the constellation of Perseus. Many people during the last days have been taking advantage of the good weather that we are having, in fact, to actually do some deep sky photographs with this instrument. So you can see here the M81, M82. It is quite fascinating that you can actually penetrate so far out into the universe, even from a location which is far from optimal, because the night sky is not very dark here, but nevertheless this can be achieved. You have the Owl Nebula here, the M97 and the M108 Messier galaxy. Galaxies in the Virgo super galaxy cluster, and now we are looking at distances of about 60 million light years. The Hamburger galaxy here, and even further away, about 300 million light years away, you have another galaxy cluster in the so-called Coma galaxy cluster. A couple of other rather special looking galaxies with rather strange interactions between obviously several objects there at the same time. Rather far out in the universe with this little telescope. But even more impressive, this is another colleague who has been using a 5 centimeter refractor with a very good camera, yes, but only 5 centimeter. He is located at a somewhat darker spot than the observatory we saw, and he has been focusing on this single object for quite some time, known as the Spaghetti Nebula. This nebula was discovered as late as in 1952 with the major Schmidt telescope observations. It is a very weak object, very difficult, in fact, to observe. It is also large. It's about 3 degrees on the sky. But he has been using 5-minute exposures for about 30 hours consecutively. Well, consecutively, but not all at the same time, obviously. So he has integrated quite a lot of light during quite some time, and this is a rather amazing result that he gets. This is a remnant, of course, of a supernova. You might guess that. Okay, so we have problems with less and less darkness, but of course we can still observe the sun. And another colleague has been doing that for the last 25 years, in fact, as often as he has been able to do it. And he's been using a moderate-sized Celestron 8-inch telescope during all these years. And what we see here is an accumulation of all his observations up to date. As you see, for the last 25 years solar activity. So he has been watching the sun, he has been counting sunspots, and he has computing what is known as a solar activity number. So he has been following, as you see, three at least solar maxima. One in the beginning of this century, and then one in 2013. And now the latest one, as you can see, it is now going down after the latest solar activity maximum. So each of the white dots is a single observation. It's one day, and the red squares are averages for about a week at a time. So it's a rather unique set of solar observations made by a single observer. Here you can see the latest maximum, how it has risen and is now obviously declining again. So if you have sun and you have activity on the sun, you also have this northern lights. And these are a couple of images I received just a couple of days ago, and they are taken in the beginning of April from a very far up north in Sweden, close to the little city of Jokkmokk, and it's close to the polar circle. And there you really have spectacular aurora, and some of these images show that quite well. Quite amazing. I've never myself been able to see this kind of a fantastic northern lights or aurora. So, well, there you are. So this is a little bit what has been happening here in Sweden during the month of April. So good luck to all of you out there, and hope to see you at some soon in time.
That was great. Thank you very much, Peter, for a wonderful presentation of astronomy, basically, in Sweden. And Peter has been very integral in doing a lot of outreach, and he's a professional astronomer, but also has a passion as a hobby for astronomy too, which is absolutely fantastic and really gives a lot to astronomy. So thank you very much, Peter. He's just one of dozens of national coordinators that we have around the world representing different countries. And it's just lovely to see all the efforts and the imaging and the connection that the people have with at the telescope is really incredible. So maybe we can see again, we can get back and see what's happening in out in Cyprus. We're gonna ask to unmute. Let's see if George, can you hear me? Can you unmute your mic? We can see you're outside. Let's see if George can unmute his mic. He is there, I think, trying to show some nice things. So we're actually looking at the night sky as it appears in Cyprus right now, live on April 25th, Saturday. Yes, George, we can't hear you. Do you have your mic? Can you unmute your mic?
Yes,
Oh,
again.
there we
So
are.
we are here outside. We are observing with the Dobsonian telescope now Venus, because it's very, very low near the horizon, and it's there. And then we are going to observe Jupiter, and then we're going to observe the moon.
That's
The
fantastic.
moon and Jupiter, we will observe it from the observatory. But here we have the Dobsonian now observing outside the observatory, we're observing Venus.
Oh, that's wonderful. George, can you try to
I
put
hope that my battery will last. I have only 6%, going 5 now, to give you some images from the observatory, but maybe I can. Everybody finished? Okay. Guys, everybody observe from here. Okay, shall we leave it here, and now I will proceed. You can proceed with the observatory. I'm coming to join you. Okay. We meet somebody he didn't observe. He was walking away from the telescope. Okay. So we are going to enter now the observatory. Show you how it is inside. And we need the keys of the observatory, first of all. Alexander, you have the keys? Yes.
This is the beauty of
Yes.
live stream.
We,
We're looking for keys to get into the observatory.
yes, Alexander is doing the last couple of observations. So
So it looks like clear
we
skies. You have clear skies there.
there is dust actually, but it's it's better than earlier. But we have a really big problem now with light pollution. When we came here 18 years ago, or 18 and a half years ago, we were alone in the wilderness. Now they have developed the plots, and here is the street lights. As you see here, we complained to the electricity authority, and they moved the lamp so it will not show on the observatory, and it shows on the tree. And one side of the tree is without leaves, and the part of the tree that the light is beamed on it, it has leaves. So it believes that it's summer throughout the year. So
Yeah.
this is how by the biodiversity, a real example of biodiversity being destroyed by light pollution. And
Oh, George.
he will come.
George, can you
Yes.
see? Can you try to put see if you put your camera horizontal instead of vertical? Let's see if what happens. If you turn
Okay,
your
I'll try to put horizontal.
does it? Oh yeah, now we have the entire. Now that's
You
better.
have the entire view.
Yeah, this is not much
Okay.
nicer. Yeah, it looks
Okay.
great. Oh, there's the moon.
Is the moon?
Live
I
from
can.
Cyprus. This is the moon.
And there is Jupiter.
Oh yeah, we can see Jupiter. That's the dot that's in the center of the screen
Yes,
right now.
and I will show you Venus as well. And we have Castor and Pollux on top of it. I don't know if they're visible. And we have
Where's Venus? Ah,
Venus.
oh, that's beautiful. I could see the palm trees underneath.
Yes, nice. Yes, but you can also see the light pollution that was brought
There
here
is
since
a
last
lot.
May.
Yeah. Yeah.
You see, look at this example of, maybe we can point that out and give us an example, global example. Do you see let me repeat what I said earlier now that it's being really visible. So we complained to the local authorities, and they just moved to at an angle the light there, so that it will not show the beam. It will not beam the light directly into the observatory. And we asked them to turn it off. Nothing happened. It was total darkness here 18 years ago. We used to have to observe with the naked eye 6.5 apparent magnitude stars. We can still observe 5, but there is a lot of problem with these lamps. They are LEDs. They are not like the old tungsten lamps. They are LEDs, something like 5,000 Kelvin, white light, and because they produce a lot of heat, they have removed the covers under the LEDs because they melt. So it doesn't worth changing them all the time. So they have removed them. And what is the result? The light spreads everywhere.
Yeah. Yeah.
And look at the fig tree there. Usually at this time, it's the time that they start to grow a few leaves. But throughout the year, even in winter, when all the leaves, when the tree leaves loses all its leaves, the place where the light beams is beamed onto the fig tree, the biodiversity is being destroyed, of course, generally by the light pollution. But there you can see a real example that on the right side, where the light, the biggest amount of light is falling, there are more leaves than the other part.
Yes.
Of the fig tree.
There's a lot
And
of like a
that's all over
wash
the
of
year.
light. Yeah. Yeah, you can see it clearly.
Hmm.
Yeah.
So let's now move here to the dome. Let me take you to the window, if I may. It's not visible there. We have the Big Dipper here. I don't know I'm not sure if it's visible.
Nope, I don't think
Big
I see
Dipper.
it.
No. Okay, and I'll try to show you something from the dome.
Ah,
Yes. We have our German friends here. We are inside the. Mhm.
yeah, I can hear a lot of people in there.
Yeah, something like 4 or 5 people at the dome
So
at the
we're
time.
inside the observatory now.
Yes, but we have lights off because we are observing. We don't even have the red light on because we are observing Jupiter.
Direction of the moons.
And here is Jupiter and the moon.
Oh yeah, you can see Jupiter is the dot that's on the lower right, and then the moon is, of
Yes.
course, up on the upper left.
But you
And I took a screenshot of this.
The red eye is on our side.
I don't know. One second.
Jupiter turns around. Super view.
Good quality. Yeah.
Let me see if I can turn on the red light.
And what size telescope do you have in there?
Okay, I have the red light on now. This is the Meet LX90, 8 inches. And on the other dome that we have the LX200 GPS, 16 inches with GPS module, auto line. So this is the one that we have for science outreach, for the guests, for the public, the 8 inches telescope. And the one that we use for research is the 16-inch telescope. Still meet.
So
We also
can see
have the
that. Yeah.
radio telescope and the Dobsonian that we used outside, 8 inches. And we also have Coronado for hydrogen alpha for the sun. And we also have filters here for the photosphere that we use.
Oh, there we can really see. That's a nice view. We can see someone looking through the telescope now, eh? So
We don't
George,
we don't
maybe.
have it automated. We don't have it on the auto tracker so that we correct the image so that we don't break the gears during the public events, and we don't connect it to the computer so that the people will actually get the hands-on experience. Otherwise, they could watch it from YouTube. So we didn't connect the computers, we didn't connect the network, we didn't connect anything. We just have it and working it, or we did manually.
By distance.
And we have our friend here observing.
And George, maybe you can tell the audience why you have red light. What's the function of the red light?
The LED light to preserve I have a flat battery, it will go off. Oh Jesus. So it will be interrupted in 4 seconds because battery is going off. Andrew?
Yes, I can hear you.
The
Oh, I think we lost George. I think so. Yeah. So we were watching Cyprus. And wasn't that amazing? I thought that was really cool. We actually got to see inside the observatory live. They're actually doing viewing right now in Cyprus with a public star party in the observatory at the Kidian Observatory. And we saw public folks watching Jupiter and the moon, they're kind of right now at amazing viewing opportunity. So if you've got clear skies where you are, that's something that you definitely want to do, is to go outside and view the night sky. So listen up, guys. We've got more coming your way today for our global star party. We're going to be joined by folks in Romania. We're going to be visiting Romania and also Israel and Belgium. So we've got a few more really interesting views for you, I think, viewing around the world, looking at astronomy being done in different countries as the night sets in. So please do come back. We should be back on air in about a half hour from now. I'm actually in Montreal, Canada, where it's early afternoon. It's just 1:28 p.m. where I am. And so at 2 p.m., which is, I think, 1800 Universal Time, we will be back. So in about a half hour, come on back, and we'll be joined by some other places around the world, star parties, presentations, amateur astronomers, some really cool stuff. So come on back. It really showcases how astronomy is for everyone. It's a lot of fun. Hey, listen, if you find events, if you like astronomical events like this, come on back. We'll have more interesting stuff from Israel, Romania, and Belgium as well. Guests coming on by, sharing astronomy where they are located. So it'll be a lot of fun. And if you like this kind of programming, please consider donating to Astronomers Without Borders. You can go to gam-awb.org. Log on there and you'll see all kinds of interesting things of what else is happening in Global Astronomy Month and how you can help support our nonprofit as well. Also, just a big shout out for our next event. I don't want you to forget. We will have, as our next webinar in part of Global Astronomy Month, is Smart Scopes for Beginners. Hey, listen, these really cool little small gadgets are opening up the night sky like never before, and we'd love you to join us on April 28th at 1800 Universal Time. We'll have a live webinar, a live stream from our Facebook and YouTube channels, and so we'll be able to showcase some really cool stuff for you. So come on by. In a half hour, we'll be returning to show some more interesting things coming around the world. Stay tuned.
From the pale blue dot to the distant stars, we are one. One people, one sky.